Hi, welcome back to this channel. In this video, we're going to start with chapter amino acid. These are the learning objectives in this video. We need to know the general structure for amino acid, and then also can give the IUPAC name, identify the meaning of the zwitterion, isoelectric point, and draw the structure in these three situations: acidic, medium, basic medium, and PI condition. The general structure of the alpha amino acid generally always consists of two functional groups. The first one is an amino group and the carboxyl group. So between these two carboxyl group, between these two functional group, carboxyl group has the priority, so we'll label as carbon 1. And both group basically will attach to the same carbon, and this carbon will known as alpha carbon. So the general structure of the amino acid will known as alpha amino acid. Okay, let's start with tutorial question number 2. We start by drawing the structure first. Question A, 2-amino 3-methylbutanoic acid. So we start with the butanoic acid, consists of 4 carbon, 1, 2, 3, 4. And then draw the carboxyl group first. So the carbon with the carboxyl group will be considered as carbon 1. So carbon 2 will attach to amino group NH2, carbon 3 attach to methyl CH3. Then now only we complete with the hydrogen CH3, CH, CH. So this is the structure for 2-amino 3-methylbutanoic acid. So let's proceed to B, 2-amino 3-phenylpropanoic acid. So propanoic acid consists of 3 carbon. Also complete with the carboxyl group first. Second carbon will going to have amino group, while the third carbon will have the phenyl group. So and then complete with the hydrogen CH2, CH. Next, question C, 2-amino 3-hydroxyl propanoic acid. So propanoic acid 3 carbon as well. So come with 3 carbon. Carboxyl group, second carbon with amino group, third carbon with the hydroxyl group, so CH2, CH. Last question, question D, pentane dioic acid. So again, pentane have 5 carbon, so draw 5 carbon. So once we have dioic acid, means that there is both 2 carboxyl group at the terminal left and terminal right. So then we have 2 amino groups, so you can use the carbon at the most left hand side as the carbon 1 also okay. The carboxyl group at the most right hand side as carbon 1 also okay. So let's say we put this one as carbon number 2, so NH2, this one still need another 1 hydrogen, this one need 2 hydrogen, this one also need 2 hydrogen. So these are the structure that we can draw based on the question asking. Okay, then after we learn the drawing, then now we're going to name the compound. So before we name the compound, the question first part A is asked us to define the alpha amino acid. So basically the keyword is both amino and carboxyl group attached to the same carbon. Attached to same carbon. Okay, and then they also ask us to draw the general structure, which consists of a carbon and then with C double bond O, CH, and then must have another bond is NH2. So both up here we can consider it is hydrogen, or we can simplify in the middle here as CH2. Okay, then now we proceed to B. Before we can name this, as usual, we have to identify the longest carbon chain. So the carbon with the carboxyl group will be first carbon, second carbon, third carbon, fourth carbon and fifth carbon. So this one, 1, 2, 3, 1, 2, 3, 4, 5, 6. For this one is 1, 2, and 3. This one, 1, 2, 3, 4. Okay, so after identify the longest carbon chain, then now we can do the naming. So carbon 1, carbon 2, 3, 4, 5. So will be pentanoate. So and then we have 2 amino, 3 methyl. 2 amino, 3 methyl pentanoic acid. Okay, so for the question B2, just now we already identified 1, 2, 3, 4, 5, 6. So it's hexanoic acid. And then we also have 2 substitute, carbon 2 and carbon 6. So will be 2, 6 diamino hexanoic acid. Okay, this one supposedly is connected to each other. There is no space in between O and H. Okay, next one we go to the question number 3, carbon 1, carbon 2, carbon 3, and carbon 4. So this one is butandioic acid because we have COOH, COOH. So and then carbon 2 with the amino, so will be 2 amino butandioic acid. Question number 4. 1, 2, 3, 4. Okay, butanoic acid also butanoic acid. And then carbon 2 has amino, carbon 3 have hydroxyl. So amino come first because with the we follow the alphabetical order, and then 3 hydroxy butanoic acid. Okay, so this one we can erase. Okay, there is one more question. Carbon, let's identify the longest carbon chain. Carbon 1, carbon 2, carbon 3, and carbon 4. So from here we know that the name of the compound will be butanoic acid. Carbon 2 consists of amino, and then carbon 4 consists of phenyl. So 2 amino, 4 phenyl butanoic acid. Okay, now we look at a few physical properties of the amino acid. Generally, they are white crystallized solid due to their have the dipolar ion. So the compound also, when they are acids as the dipolar ion, we can know them as zwitterion. So what is the meaning of zwitterion? So zwitterion means that the amino acid consists of both positive and negative charge at the same molecule but at different atom with the net charge equal to 0. So in the neutral condition and in the solid state, the amino acid will act as zwitterion. So how this zwitterion is produced basically is the proton from the COOH donated to NH2. So this NH2 will become NH3 plus and the COOH will become COO negative. So with this then both positive and negative charge are exist in the same molecule. So the amino acid are the amphoteric, means that they can act as acid because of the presence of COOH. At the same time, they also can act as base due to the amino group. So when this case happens, their pH value is equal to Pi. Okay, based on the statement above, the slide above, we able to answer the tutorial question number 4. Glycine 2-amino ethanoic acid is solid with high melting point. So we want to describe why. This is the first point. And then second, why the glycine soluble in water. and the third one, why they are insoluble in ether. So the first one, since we know that they are in the solid form, so because of they form in the zwitterion, dipolar ion. In this case, they will going to have strong electrostatic force between the NH3 plus and the COO negative. So cause the boiling point or the melting point is higher, and due to the higher melting point and boiling point, they will exist as solid in room temperature. Second, we're going to explain why it's able to dissolve or soluble in water. Because they can form amino acid, can form the hydrogen bond with water and also with its own molecule. The third one is the insoluble in ether. Why this happen? Because ether is non-polar solvent. So that's why they are insoluble in non-polar solvent. Okay, so again, now we learn how to draw the structure of the zwitterion. Before that, let's recall the meaning of zwitterion is when the proton, which is the H in the COOH group, is donated to amino group. So from here we can see the bond will break between O and H, and then this hydrogen will donated to amino group. So once the bond break between O and H, we will get the structure COO negative. And when this proton is donated to the NH2, it will become NH3 plus. So and then this compound consists of two polar, which is positive and negative. So we generally can use the term zwitterion. At the same time, it also fulfills the definition of zwitterion with the no net charge, which means the net charge is equal to 0. Okay, so now we proceed with the isoelectric point. Basically, isoelectric point is the pH value when the concentration of zwitterion is at the maximum. So at the pi, zwitterion has no net charge. Okay, so each amino acid will going to have its own specific pi value. Okay, maybe we can know better when we proceed to the tutorial question number 5. Based on the structure below is aspartic acid. It is an acidic or base, and then explain your answer by drawing the structure of zwitterion. So let's draw the zwitterion first. So in this structure, you can see there are two carboxyl group, and then there is one amino group. So as we know, zwitterion has no charge. Okay, so means that only one COOH group will donate the proton to the NH2. So in between these two groups, group A and group B, the carboxyl group of group A and B, so definitely A will donate the proton to the amino group. Okay, due to the distance, we can remember like this. So if this happens, so the NH2 will become NH3 plus, bonded to CH, and then the COOH will become COO negative. Then we have CH2, and then we continue with COOH. So this is the structure of the zwitterion. Don't forget that we need to determine whether this aspartic acid is acidic or base. So due to the presence of the carboxyl group, basically we can consider this aspartic acid is acidic compound due to they have extra one carboxyl group. Then now we go back to question number 3. What is the zwitterion? So I think we already repeat this a few times. So again, generally the zwitterion is a molecule with the overall charge of 0, and then consists of positively charged group at one part and also the negatively charged at another part of the same molecule. So now we need to draw the structure for the zwitterion. The first one is 2-amino 3-hydroxy butanoic acid. So 4 carbon. So this is why drawing the organic compound based on the name given is very important. So then we have butanoic acid, we have COOH. So we know that the hydrogen will donated to the amino group. So we can directly make the NH2 become NH3 plus, and then we proceed with the OH at the third carbon, and now we complete with the hydrogen. Okay, so this is the structure for the B1 threonine. Next one is the alanine 2-amino propanoic acid. So we're going to start with 3 carbon propanoic acid again. The COOH, I will make it become COO negative, and then the 2-amino will become NH2 will become NH3 plus. Then only I complete with the hydrogen. Okay, so I think that's all for this question. Okay, now let's continue with tutorial question number 6. The isoelectric point for the 2,6-diaminohexanoic acid is 9.5. This is the pI value. Draw the structural formula when the pH equal to 1, 9.5, and 12. So if this is the case happen, so I always will draw the structure at pI, because at the pI it is a zwitterion. So let's start with the 2,6-diaminohexanoic acid. 1, 2, 3, 4, 5, and 6. So the 6 carbon, which is also can be considered as the first carbon, as carbon 1, and then we will have carbon 2 and we'll have amino group, and then the carbon 6 also will have amino group. Then we complete with the hydrogen, CH2, 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 and this one will be CH. So because we already understand during the pI condition, it will exist at zwitterion. So let's draw the structure of zwitterion at where the H from the COOH will be donated to amino group, so which will be NH3 plus. So only the H only will donated to one amino group because there is only one carboxyl group. Okay, and then we have 2 amino group. Which one will be donated? For sure, the one which is nearer to the COOH. So this one will be the structure for the zwitterion. So when at pH equal to 1, means that this is the acidic condition. So as we know, the symbol to represent acid condition is H+. So now you imagine that H+ is going to add to the zwitterion. So what will happen to the zwitterion? So first, the NH2 is the base, which will react with the acid, so also will become NH3+. And then we proceed with CH2, 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 and then CH. The NH3+, which is in the zwitterion, will not react with the H+, so maintain. However, the COO negative at the zwitterion will react with the H+ to form COOH. So this is the structure of the 2,6-diaminohexanoic acid when it is in the acidic medium. So the pH equal to 12 is represent the basic condition. So at where you imagine that OH negative will be added. So again, we also start from the zwitterion, CH2. The NH2 amino group is base. OH negative also base, so will not react with each other. CH2, so 1, 2, 3. So I simplify, condense it becomes CH2, 3, and then CH. Now this time we have the NH3+, able to react with OH negative. If this happen, we will get NH2. The H+ from the NH3+ will combine with the OH negative to become H2O. okay, which we no need to write down this one also okay, because the structure is asked us to draw the structure for the leucine. Okay, and then the another part, COO negative will be maintained because COO negative won't react with OH negative. Negative will repel each other. So we already complete for the question number 6. Okay, one more example from question number 8. Isoleucine is an essential amino. Draw the structure at pH equal to 12, pH equal to pH equal to 2, pH equal to 12 pi, and then give the product. So we only will stop at here because that is the chemical react properties of amino acid. Okay, we just add the zwitterion first. Okay, so 2-amino 3-methyl pentanoic acid. Maybe you can start by drawing the amino acid based on the IUPAC name. So pentanoid 5 carbon. So second carbon with the amino group, third carbon with the methyl group. So CH3, CH2, CH, CH, and this one will be C double bond O, OH. So then now we try to draw the structure at Pi first. So CH3, CH2, CH, CH3 maintain, and then we have CH. The NH2 will become NH3 plus, and the COOH will become COO negative. So then now at the pH equal to 2, so we consider that the H plus is added. So imagine that we have CH3, CH2, CH, CH3, CH. When the H plus added, the NH3 plus will not react with the H plus because they have same charge. And then the COO negative will react with the H plus become COOH. Next one is when the pH equal to 12, which we consider OH negative is added. So in this case, we have CH3, CH2, CH, CH3, CH. The NH3 will become NH2 plus. NH2 only, and then the H plus will react with the OH negative to form H2O, and the COO negative will remain the same again because of negative and negative, they will repel each other. So basically, we already complete the first part of the amino acid, which we can draw the structure of the amino acid, can understand the meaning of zwitterion, isoelectric point, and draw the structure for zwitterion, and also in the acidic and basic medium. So in next video, we will going to discuss the chemical properties of amino acid. See you.